This afternoon I'm going to be talking to you about how to use Pythagoras Theorem to find the distance between any 2 points in the world. Not just like this point and this point, but this point and 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 this point. Any 2 points in a two-dimensional world. It can be done in a three-dimensional world as well, which I might touch on briefly near the end of the video. But this is a video for using Pythagoras. If you don't know what Pythagoras is and you can't remember, there is another video in the channel which is all about using Pythagoras Theorem. Go and watch that first, then come back and watch this, and I'll wait. No, I'm serious. Come back and watch this video once you know what Pythagoras Theorem is. So how are you? I hope you had a good weekend. We are first of all going to go straight into my whiteboard. This might not be a long lesson, but it's going to be a lesson with some learning on it. So they're the best lessons, right? In fact, why am I ever doing lessons that aren't some learning on it? Right, I have here 2 points in the world. In a two-dimensional grid, we have points going on the x-axis and we have points going on the y-axis. So you can see this point here is 3, 2, and this point here is 7, 5. We can find the distance between, a direct distance between any 2 points by first joining them up. What we then do is go along and up. And there's two ways we can do this. We can either count the squares, 1, 2, 3, 1, 2, 3, 4, or if you just do it without the coordinates, without the grid, sorry, hopefully it's clear to see that the distance between these, that has changed by 4 and that has changed by 3. When finding the distance, it does not matter whether they've gone up or down or left or right. It's just the excuse me. Sneeze in the middle of the live streams. Must be hay fever. Must be all these. Oh, it's this fake plant I've got up here. Must be causing hay fever. So we've got that's 3, that's 4. Now what we do is we use Pythagoras and we go, well, we're going to take the 3 and square it. We're going to take the 4 and square it. So we've got 9 and 16. We're going to add those together, giving us 25. We're going to square root the 25, giving us the answer 5. And that tells us that this distance must be 5. And this can be done in any position. What it means is you can that a computer can be programmed to graphically have lengths of certain lines. Now, if you've ever used a graphics package to draw a 4 centimeter line, it will be able to reverse engineer this to make sure that it's going along and up with the right number of pixels. Because if we think about a computer screen, it is made up of loads of pixels going along the bottom and loads of pixels going up the side. And it's lighting the right pixels. It's thousands of pixels by thousands of pixels. I think mine's something like 1600 by 1082, something like that. But it's thousands of pixels along the bottom, and it's got to know which ones to light up to make it so that it's got this line. We're going to do a different one. Now, ideally, we shall do that with just a grid. So what we're going to do is we're going to get rid of all of this, and we're just going to have a question where we've got the coordinates of the points instead of actually drawing them. So the question may now say, what is the distance between the point 7, 10 and the point 2, 19? So what we do, 7, 10, 2, 19. Now I did say to you earlier, because it's the distance between them, let's show a physical representation of this. 7, 10 and 2, 19. So if I draw a dotted line here and a dotted line here, in order to find this distance, we just need to know what the change in the side is. And I think that's changed by 5. Yes, it's gone left, but it doesn't matter. It's 5 squares. This one has gone 9, so it's 9. Now we use Pythagoras. The rules for Pythagoras were 5 squared, because we've got this right angled triangle, 9 squared, and then add them together. So we've got 5 squared is 25. And good morning, Adeline. And 9 squared is 81. And we're going to add them together, giving us 106. So once we've got 106, we now need to square root 106 to say what that distance is. Now I can use my calculator, which I've taken to school this morning, so it's possibly even round the corner somewhere in my bag. Fortunately, I have a fail-safe for this. I just bring up my emulator and go straight with my current license. Here it is. And we're going to do the square root of 106. I can tell you it's going to be 10.3. And it is 10.29, which rounds to 10.3. Mr. Harris celebrates a win by running around the block 5 times. 10.3, and again, there's no units because we haven't got units. If this was centimetres or centimetres, it would be 10.3 centimetres. It is the distance between these 2 points. So this lesson is all about any 2 points. You can even, let me just demonstrate. What if, sir, I hear you ask, from the comfort of your own living room, what if it was -4, 7, and 6 minus 10? Can we do it in that scenario? Well, young mysterious person, -4, 7 is here, and 6 minus 10 here. And if we want to find this distance here, we're going to need to do a triangle. And the reason this works is because whatever the points are, you can always make a right angled triangle by counting how many go along and how many go up the side. Let's just do it. -4 has turned into 6, and 7 has turned into -10. It doesn't matter if it's gone up or down, we know it's changed by 10. 4 gets it to 0, 6 more up to 6. This has changed by 17. 7 gets down to 0, 10 more to make it to -10. So the change is 17 and the change is 10. So we're going to go 10s there, 17 there. We've got 10 squared is 100, 17 squared is, I want to say 343, but I'm going to check it. 17 squared is 289. This is why you check. 19 must be 343. 289. Add them together, 389. It's just short of 400, which would be 20. So I'm going to gamble and say 19.7. But then we're going to do it, 19.7. So we want the square root of 389. And we're gambling on 19.7. Square root of 389. 19.7. I'll tell you what, I should teach maths. That's what I should do. Like with all this, getting the square roots correct, this magic stuff. Eddie, you're absolutely right. It's using Pythagoras Theorem to find the distance between 2 points. We are always going to be, anytime you've got 2 points to find the distance between, it's using Pythagoras Theorem to help you. Okay, so I've already got a video on Pythagoras Theorem from scratch. This is using it, but it's always going to be a plus version because it won't give you the distance between the points. It will tell you, and you have to work out the distance by using how much it's changed in the coordinates. So it's just understanding that when we've got the points, what's the change? And when we've got something like this, I often think a stepping stone to 0 is useful. So it's got 4 to 0 and 0, so that's why it's 10, because it's gone to 0 first in the middle. Okay, so that the steps for doing this are very straightforward. It's where does it start, where does it end, how much has it changed? Where does it start, where does it end, how much has it changed? We're just trying to turn one coordinate into another coordinate and use it, nice to see you Alex, to find the gap between 2 different points. Once you know the gap, once you know the 2 points, find the gaps, square them both, add them together and square out your answer. I am well aware this has just been a 10-minute video. This is because sometimes the video it's about teaching you a point. The next thing to do is go and click on the link in the description and practice it. While it's fresh in your memory, you might want to rewind and watch a bit again. It doesn't always have to be a long 25-minute, half-an-hour video when the point of the subject is how you do this. This has shown you how you do it. It's now your job to go away and practice it. I hope you've learned something today. If you've got any questions, I'm around. Can you do one where you know the hypotenuse and you have to find a different side? Absolutely, Jarvis. Right. The difficulty of this is, because this is all about the distance between 2 points, the only way we can do that is if we were told that the distance between 4, 7 and something is 6. It's the only way you could do it, and it doesn't really make sense, because what that says is 4, 7 is here. 4, 7. If you think of all the places that could be 6 from there, actually, I need to make it a bit higher, I think. All the places that are 6 from there, it would actually go like this. Not the best. They are all 6 away. So this one would work, but so would this one and this one. There's actually lots of answers. This is why I haven't done it with one that way around, Jarvis, because when you're using it with the distance between 2 points, 2 points have a distance of 6, but lots of points also have a distance of 6. From 4 to 7. All of these places, if I use a thick squodge, every single point I'm about to mark on here has a distance of 6, if that was a better circle, from the centre. And so there are lots of questions where the answer could be the gap is 6. But what we're thinking about is, if we had this, it would be very difficult to know which answer we're talking about. It could be that one, that one, that one. But what we're focusing on is, if it then said to us, it didn't know the 6, but it did know the points, suddenly it changes from being an everything question to 12. It changes from being a lots of answer question to a single answer question, because soon as that's happened, there is only one distance we're talking about, from 4, 7 to 2, 12. This is the reason, Jarvis, I have not done it the other way around, because it makes sense when there's these 2 points. There's only one distance between them. If I'm dealing with a distance of 6, there's lots of points that could be that far away. I hope that makes sense. Eddie, you're absolutely right. It would have infinite answers. If you used decimals as well as whole numbers, there are infinite answers. And so trying to show you infinite answers is very difficult. Whereas I can show you the distance between 2 points just by going, 4 and 2 has a distance of 2, and 7 and 12 is 5, 2 squared is 4, and 5 squared is 25. That makes 29. Square root of 29 is approximately, if 25 is 5, it must be 5.4, and that is how we work out the distance between 2 points. I appreciate your question. It really is useful, Jarvis. Honestly, it is. I hope I've answered why I haven't done any like that. This has been the whole lesson. I hope this 15 minutes has helped you. Go away and practice it. I've been Mr. Harris. You haven't. Look after yourselves.